All right, we are going to take a look at graphing f of x equals ax squared plus bx plus c. So there are a few things that are going to help us to do this. So our graph is going to open up or be concave up when a is greater than 0, and it will open down or be concave down when a is less than 0. We've already seen that. C will determine our y-intercept. So any quadratic in the form ax squared plus bx plus c, that c value will tell us our y-intercept. So it will be at 0, c. The x-coordinate of our vertex will be at negative b over 2a, so we can calculate that. And that means that our axis of symmetry will be x equals negative b over 2a. So we're going to look at an example of this. So we have a function f of x equals 2x squared plus 8x minus 1. And we're going to go ahead and find our axis of symmetry. So as a reminder, as we're looking at this graph up here, that would be our axis of symmetry, where our vertex will always be as well. So here we have b equals 8 and a equals 2. So we know that our axis of symmetry will be x equals negative b over 2a. So that means negative 8 over 2 times 2. So that's negative 8 over 4. So our axis of symmetry will be at x equals negative 2. Then if we have our axis of symmetry, we can find our vertex. So we know that the x-coordinate of the vertex is negative 2, and then we can use our function to find the y-coordinate of the vertex. So in other words, if we know that this here is negative 2, we can substitute that into our equation to find what our y value will be, and therefore we would know where our vertex is. So we take the function f of x equals 2x squared plus 8x minus 1, and we substitute negative 2. So negative 2 squared would be 4, and 2 times 4 is 8. 8 plus negative 16 minus 1. So that would give us negative 8 minus 1. We get negative 9. So we know that our vertex would be at the point negative 2, negative 9. Now let's look at an example of graphing this. So if we want to graph this function, f of x equals 3x squared minus 6x plus 5, we can again find our axis of symmetry first to help us then find our vertex. So we know once again that x equals negative b over 2a, and this time b is negative 6. So if we've got negative b, then that's going to be negative negative 6, which is positive 6. And that will be divided by 2 times 3, which is 6. So the x-coordinate here is going to be 1. So once again, we can find our vertex because we know that the vertex will be at x equals 1. So if we substitute that here, we have 3 times 1 squared minus 6 times 1 plus 5. 1 squared is 1, so we have 3 minus 6 plus 5. That's negative 3 plus 5, which is 2. So we know that our vertex will be at 1, 2, and we could go ahead and graph that. So there's the point for our vertex. And then we also know, based on this form, c will tell us the y value of our y-intercept. So if c is 5, that means our y-intercept will be at 0, 5. Now, because we have our y-intercept and our axis of symmetry, we could actually plot another point here because we know that our function will be symmetrical across this point here, which means we can also plot a point at 2, 5. And from there, now we have enough points that we could draw our graph. All right. Now, maximum and minimum values. So that's just simply our vertex. And you can see that if we have a graph that is concave down, it will have a maximum, a highest possible point. And if it's concave up, it will have a minimum. So that's pretty straightforward. We know that if A is greater than 1, then it's going to, A is greater than 0, then we're going to have a minimum because it will be concave up. And if A is less than 0, we will have a maximum since the graph will be concave down. So looking at this first one, tell whether the function f of x equals negative 4x squared minus 24x minus 19 has a minimum value or a maximum value. So we know, looking at it, it says A is negative 4. So we know that our parabola will have this type of shape, meaning it will have a maximum. So this will have a maximum. And then we could actually find the value of that maximum by using, once again, x equals negative b over 2a. So we can see that b is negative 24. So we're going to have positive 24 divided by 2a. So in this case, that's 2 times negative 4, which is negative 8. And we get negative 3. So the x-coordinate of our vertex will be negative 3. And once again, we can substitute that into our function to find the y-coordinate of the vertex. So negative 4 times negative 3 squared minus 24 times negative 3 minus 19. So that's negative 4 times 9, which is negative 36 minus 72 minus 19, and we get a total of negative 127. So that means our vertex would be at the point negative 3, negative 127. Finally, looking at this last example, finding a minimum value. It says the suspension cables between the two towers of the Mackinac Bridge in Michigan form a parabola that can be modeled by y equals 0.000098 x squared minus 0.37x plus 552, where x and y are measured in feet. What is the height of the cable above the water at its lowest point? So we can see here, right, the water would mark 0 on our graph. And we want to know, in other words, right, we want to find our minimum value. So that means we're going to need to find our vertex, which is a minimum. And once we know the y-coordinate of that vertex, we will know the height of the cable at its lowest point, at its minimum. So we start again by finding the x-coordinate of our vertex, which is going to be negative b over 2a. So b here is negative 0.37. So negative b would be 0.37. And then we can find 2a. So it's going to be 2 times 0.000098, which is 0.000196. So our x value here, if we divide, would be 1,887.7551. And we'll go ahead and round that to the nearest whole number. So we'll say x is equal to 1,888. Now, just looking at our image here, we want to just make sure that's reasonable. And we can see that our minimum is going to be slightly left of 2,000 on the x-axis. So 1,888 seems like a reasonable value here. So now that we have our x value, we can substitute that into our equation to find the y value. And again, this is something we would absolutely use a calculator for. So we have y equals 0.000098 times 1,888 squared minus 0.37 times 1,888 plus 552. Now, if we calculate that, and again, that's something we can just use a calculator for, we would ultimately get about 203 feet. Now, once again, we can just look to make sure that's reasonable. We can see that this line here would be 250 feet. So 203 feet seems like a reasonable answer for the height of this bridge.